In these problems, we have some graphs and we are determining their limits at certain points. And the basic rule to remember is that if the left-handed limit and the right-handed limit are the same value, you can say that that's the value of the limit as x approaches that value. So it's a way to test if a limit really exists there. So let's take a look at this. First, we want to find the limit as x approaches 2, and clearly 2 is this dashed line here, um, from the left, from the negative side. And as we approach from the negative side, it looks like the function's getting higher and higher. So I would say we've got an infinity there. And then from the right, well, it stays steady at -1 that whole time. And at 2, it's defined as -1. Now, even though that point is defined at 2, it doesn't mean that that's the limit there, because on the other side, the left-hand side, we're up at infinity. So since these two values don't match, we're going to say this limit does not exist. Let's try another. Okay. So here we've got an interesting looking function with an asymptote here and two lines kind of approaching that asymptote, one down at the bottom, one up at the top. And we want to find, first of all, the limit as x approaches -3. So that's where that asymptote is from the left. And as we're approaching from the left, it looks like we're shooting down really fast. So I'm going to say this is -infinity. And on the right, looks like we're shooting up really fast as we approach 3. So that's infinity. And again, these are not the same. So this does not exist. Got one more. This is an interesting one. So we have an asymptote. We've got a point where the function is defined at -2 and that value of the function is 1. And then we've got these two lines shooting up as they approach the asymptote. So from the left-handed side, as x approaches -2, we're getting further and further up. So that looks like a limit of infinity. From the right-hand side, same thing. It goes further and further up. So it looks like infinity. Therefore, the limit as x approaches -2 is infinity. If these two are the same, then we have the limit, even though the function is defined at a point that is not that limit. So that's a little bit of work with infinite limits from graphs.